which is denoted t sub n of x for a function f about your centered point A is the partial sum of the Taylor series up to n, whatever n is. So basically, we're going to take the infinite Taylor series, and we're going to cut it off at a certain value of n. And that's going to be called a Taylor polynomial, because you'll see why if we write it out. You know, a Taylor series represents a function. All right, this is a Taylor series. We find, for f of x, we find the sum, n equals 0 to infinity, of, well, it's f, the nth derivative at a, divided by this, what we're doing. That's our Taylor series, n to infinity. Well, the Taylor polynomial says, yeah, I just want to do, though, n up to n for those terms. So I'm going to cut it off at a certain point. So if I do up to n, it would just be, the first one would be n equals 0, so that would be basically just f evaluated at a, because that would be 0 factorial x minus a to the 0 is 1. So you're just talking about the function value at a. Well, if a equals n equals 1, we're talking about the first derivative at a divided by n factorial times x minus a to the first. Then if I do the second derivative, n equals 2, I'll have second derivative n factorial x minus a squared. So yeah, I'm just running through the different values of n starting at n equals 0. And I only want to go up to the nth one. So I want to end this at the nth derivative divided by n factorial times x minus a to the nth power. And that's going to be the stop. That's where I stop. Instead of going to infinity, we're only going to n. And notice, this is not going to mean, Josh was mentioning this a while ago, this is not going to mean there's n terms, is it? There's going to be how many terms? N plus 1 terms. Why? Because you start at 0. You got the 0 term, the 1 term, the 2 term, so you're going to have n plus 1 term. So anyway, we'll see that. All right. So let's find T3, the Taylor polynomial T3. Of x. Oh, and also one other term here. This is called, because n equals 3, so this is called the third degree polynomial, Taylor polynomial. And for obvious reasons, because since n is going to be the power, and I'm doing T3, what power am I going to stop with? Isn't that going to be the third power? So it's going to be third degree. So that's where that terminology comes from. Find the Taylor polynomial T3x for f of x equals x sine 3x centered at a equals 0. All right? Well, good news here is, I guess the bad news is I've got to come up with a Taylor polynomial, which is a Taylor series partial sum. However, the good news is this is centered at a equals 0, so what does that mean? It's Maclaurin series. Maclaurin series are good for us because we have that table 1. We can use the Maclaurin series. Table 1. Because on table 1 we do have a sign, don't we? A sign of x power series, Maclaurin series. What's sine of x? It's got the 2 to the n plus 1. Sine of x is the series n equals 0. It's not by any means an easy power series, but it is a known one. It's this. So from table 1, I know that the sine of x is negative 1 to the n, 2n, x to 2n plus 1 over 2 plus n, 2n plus 1 factorial. And so I can get x sine of 3x then. As a Maclaurin series, it's going to be, well, we just plug in for sine, plug it in x to be 3x there. So it'd be x sine 3x, sum n equals 0 to infinity, negative 1 to the n, 3x to the 2n plus 1, 2n plus 1 factorial, and don't forget your x here in front. X times all that. Just plug in 3x for the x. Well, that is 3 to the 2n plus 1 times x to the 2n plus 1 over 2n plus 1 factorial, because I'm going to go ahead and bring in the x with that, x to the first, so it'll be 2n plus 2 there on the end. So, oops. That's my Maclaurin series. Negative 1 to the n, 3 to the 2n plus 1, x to the 2n plus 2 over 2n plus 1 factorial. But that's not what I wanted here. I wanted the Taylor polynomial T3x. So what that means then is T3x is, it's this series, but only up to n equals 3, right? It's that series up to n equals 3, okay? For this series right here. Now again, it starts at 0, so we have at n equals 0, what have I got? Well, I got a lot. Okay. N equals 0, negative 1 to the 0 is 1. 3, n equals 0, so it'll be 3 to the 1. X, n equals 0, so it'll be x squared. Over n equals 0 will be 1 factorial. And I'll do n equals 1. Well, n equals 1, I have negative 1 to the 1. 3 to the 2n, that'd be 3 cubed. 2n, 2 times 1 plus 2, that would be 3. And 2n plus 1, n equals 1. Whoop, that'd be 4, wouldn't it? 2n plus 2 would be 4. This would be 3 factorial. Then n equals 2, I do that one. Well, that's going to be negative 1 squared, so it'll be positive 1. N equals 2, so it'll be 2 times 2 plus 1 would be 5, so 3 to the 5. 2 times 2 is 4 plus 2 would be 6. 5 factorial. And then, last but not least, n equals 3 is where I'd stop. N equals 3, it's going to be negative 1 for the power. And then n equals 3, so it'll be 7, 3 to the 7th. 8 for x to the 8th. And then 7 factorial. Clean that up a bit. I think they usually leave the factorials factorialed. They won't factorial those all out, but you can if you want to. 3x squared over 1 factorial minus 3 cubed x to the 4th over 3 factorial plus, so I'm leaving the powers as well, 3 to the 5th x to the 6th 5 factorial minus 3 to the 7th x to the 8th over 7 factorial. That's the T3x polynomial. Okay. Now, let me show you this. Is that okay? All right. So let's, I think they'll probably have you do this too. Let's take this function and this Taylor polynomial right here. And look at the graphs of those. What should we expect to happen there? If we graph these two functions, what would we expect to happen? What would you expect to happen? Well, what we're saying is this is, a fairly complicated function, and this is too, but it's only a polynomial. And so what this does is this approximates that. And matter of fact, it approximates it pretty well where? At a equals 0, centered up at a equals 0. So what we'd expect is if we graph this and then graph this, we should see some overlapping parts, and it should be around 0. So let's see if we can do that. Here is what those look like. X sine 3x. X sine 3x. Second one, 3x squared over 1 minus, 3 cubed x to the 4th over 3 factorial, which is 6, plus 3 to the 5th x to the 6th over 5 factorial, which is 120, huh? No, 6 120, okay. And then minus 3 to the 7th x to the 8 divide that by 7 factorial. I'm just going to put 7 factorial. And then graph. You may have to do a little zooming. Zoom in at 0 there. Okay, so here comes kind of interesting little curve. That's the sine x sine 3x. And the Taylor polynomial comes in, and basically they're, I don't know where we're talking, it's about this is about, right there is about, that's -1 right there. About at -1, this thing comes in, this Taylor polynomial comes in, and I'm not seeing a whole lot of difference until you get out here till positive. It's doing a pretty good job of mimicking x sine 3x right here at centered up at 0, matter of fact, from -1 to +1, which, by the way, well,